As Tyler and Rio have said before, the purpose of our paper was to see the effect of an economic sanction on the total economic health of the target nation. Other literature looked at political goals and political outcomes, or else at just the specific economic factors like wages and jobs. They didn't look at the whole picture. We felt that this might be because it was self-explanatory that economic sanctions affect the health of a country, but we still felt that it was important to analyze it empirically and test that relationship. Our hypothesis is that larger economies of more developed nations are better able to withstand economic sanctions. Thus, economic health was assumed to be a function of the size of the target nation's economy. Visually, we have H standing for health as a function of S, which would be the size or the wealth of the country. To test this, we run linear regressions using data from the Hufbauer, Schott, Elliott, and Egg 2008 database. This database collects comprehensive data on all incidents of economic sanctions from 1914 up until 2000. We had to revise down the number of data entries, however, because they included threatened cases where a country would warn that it would impose a sanction. For them, it was important for their political analysis of a sanction. However, for us, since we're looking at the physical impact on a country's health, we felt that it was important to eliminate the threatened cases and only deal with actual impositions. So we have 193 instances. Our dependent variable is economic health, obviously, and we use Hufbauer et al.'s Health and Stability Index. This measured a lot of things like GNP change, GNP per capita change, and other factors as well. However, we felt that using absolute numbers like change in GNP or GNP per capita weren't sufficient. This one measures the target country's overall economic health post-sanction, where 1 was distressed, 2 was significant problems, and 3 was strong and stable. This allowed us to see, even with the absolute number of GNP change, it didn't say where that country was before. So perhaps a small change in GNP would be able to shift a country from stability into distress, or a large one would not have that effect on a very stable economy. So we had to use the index to really see that. Our independent variable is wealth. We used a relative measure of wealth rather than an absolute. Again, the absolute didn't give us a real sense of what happens between countries that weren't maybe both of the same level. So if we had just a general absolute measure of wealth like GNP, it wouldn't tell us what the relationship was between the sender and the target. This one did allow us to see that. We used GNP ratio, and this gave us a sense of what would happen if a poor country put a sanction on another poor country, or a wealthy country on another wealthy country, rather than just a wealthy to a poor. So in addition to those variables, we had to use a control, and I'll explain a little bit later why we did that. We used sanction type as our control, and there are 3 types of sanctions in the database. First, denoted with an X, is the interruption of exports from the sender to the target. The next is M, interruption of imports by the sender from the target, and F. The third one is interruption of commercial finance, aid, and other official finance. So there's 7 different possible combinations. You'll see the first 3 are just the single types by themselves. The next 3, 4, 5, and 6 are combinations of 2, but not all 3. You'll see number 4 is F and X, but not M. 5 is X and M, but not F. And 6 is F and M, but not X. And you'll see number 7 is F, X, and M all together. And finally, later in the analysis, we utilized cost to targets GNP per capita. This allowed us to spread out the data points a little bit better, get a scatter plot that was better to see a regression line through. It also allowed us to see how real the economic sanctions effect was on the average citizen, how much they felt the impact. We thought that was also important. It was a factor that contributed to the index, so we don't feel like it's a whole separate analysis. The initial results did support our hypothesis. You'll see that the number 3, which was strong and stable, So the least effect was between countries with very small GNP ratios, meaning that they were relatively wealthy, both of them. So the relatively wealthier countries experienced less of an effect. You'll see the mid-range effects were felt in kind of the mid-range GNP ratios. They don't congregate at the edges, but more so in the middle. And finally, the most severe effects, number one, were felt with the highest GNP ratios, meaning that the target country was extremely poor in comparison to the sender. The problem with that was that that graph looked very, very noisy. You'll see in that graph that a lot of the points on all three levels were spread out so that there seemed to be outliers. To fix this, we had to control for sanction type. As I said before, there were 7 different combinations. The reason we did this was that the varying levels of commitment and political goals behind a sanction. Oftentimes in the database, we look back at the commitment level variable in there, and we saw that when a single sanction type was used, but not in combination with others, that the commitment level was often very, very low, and that it was more of a symbolic gesture than an actual attempt to change. Also, with number 7, with all 3 of them combined, oftentimes the political goal was very unrealistic, and so it was understood between the sender country and the target country that it would have no effect. When it was just combinations of 2, oftentimes there were a lot more thought put into it, and they were actually intended to have an effect. So here are all the graphs with the controls. So each graph here is a different sanction type, and they've been labeled here as well. The first 3, where it was just single types imposed, you'll see there's not a real visible relationship. The next 3, 4, 5, and 6, where it was combinations of 2 but not all 3, you'll see that there are pretty good lines in here, and what we found was that these were significant. All 3 of these were significant. Number 4 and 6, type 4 and 6, were significant at the 0.01 level. Type 5 was significant at the 0.05 level. Number 7, as you can see, is very spread out and not significant. Figure 9 combines 4, 5, and 6, the significant ones, into 1, and you'll see that there's a pretty good line, a pretty good regression could be drawn from that. Here are the correlation coefficients and the R-squared. R-squared just tells you how good of a fit it was, how much of the variance is explained by your independent variable. You'll see for all of them together, the correlation coefficient is significant at the 0.05 level, and the R-squared is about almost 9, 0.09. We don't expect to see any R-squared greater than 0.2. Just with this sort of data, we would expect that there's lots of variance in it because of human interaction. So we're expecting between 0.2 and maybe 0.1. What we find is that for the 3 types that had a good line visible in the graph, there was significance, as I said before, at different levels, and that the R-squareds were between that 0.1 and 0.2 level. Which was very good for us, saying that they do have an explanatory effect. For the figure 9, where all 3 significant ones were combined, 4, 5, and 6 were combined, you'll see a significance of the correlation coefficient and an R-squared above 0.1. It was 0.122, which we felt meant that it has a good explanatory effect. So we go further by looking at cost to target's GNP per capita, as I said before. We use this to give a better spread, so you can see the regression line better, because the index only had 3 possible values, whereas cost to target's GNP would give us a whole range. Also, it allowed us to see how much the citizens felt the effect. Here are the graphs for that. Again, you'll see the first 3 did not have a good relationship, and the next 3 types did. You can kind of see the lines here fairly well for the middle 3 types, the figure 13, 14, and 15. Figure 16 did not have a very good relationship, very scattered, and figure 17 was the combination just like before. And you can see we put the line through there actually. It was a very good fit. Again, all the correlation coefficients were as we would expect, except for type 1. Just it wasn't very significant, and the data wasn't the data points were not very linear. So we see a significance between the same types here, a little bit less for type 6. And type 2 had significance, but because we didn't see that before in the health index, we didn't include it in the combination one down here. Again, the combination of 4, 5, and 6 proved significant at the 0.01 level, and we had a 0.12 R-squared, which we still felt was very good. So kind of concluding the results, we found that there is a significant relationship between a nation's relative wealth and the severity of the effect of an economic sanction. The exact relationship is that relatively wealthy countries experience less of an impact on economic health than relatively poor countries. And that relationship was strongest among types 4, 5, and 6, as we discussed before. And that is the results of our analysis.